A new SAT data translator makes BIM and digital prototyping workflows easier and more cost-effective than ever by enabling designers to move solid-based design data between 3ds Max Design 2011 and Revit, Inventor, Alias Studio, or third-party CAD products such as SolidWorks, Rhino, and Formz. This now opens the door for organic shape exploration using the new body object tools. 3ds Max Design up to now always treated data as meshes, but now with the body object it holds solid data information in the Max memory. I have started my modeling using standard primitive that I then convert into body objects. I can use the tool set that I have mesh-like editing feature such as delete faces, flip normals, attach and detach. The body object also supports spatial deformers such as bend, taper, twist, and FFD box. These deformers retain the NURBS-based structure and also can be animated. So here I have deformed most of my initial object into organic shape and started to explore various options for my design. I can also use the body utility to perform operation on multiple selected bodies all at once, such as changing the viewport display setting from coarse to fine. From here, I'm ready to export these objects. So I'm going to go to the File menu, Export, choose the SAT format, name my file, and just hit Save. The SAT export window will open, allowing you to choose various exporting options. Once in Revit, while creating an in-place model, you will be able to import directly your SAT file exported from 3ds Max, and you will receive a nice and clean model. From here, you'll be able to further develop your concept by either applying a series of floors and looking at how this model is reacting, or applying some walls on those faces or curtain walls. Because you're not losing any information when importing your SAT file, you can then start moving forward with your project without losing any time. In the same state of mind, it is also possible to export a mass model created in Revit over to 3ds Max Design using the SAT format. Because Revit is a solid modeler, you will keep the information while importing in 3ds Max. This shape came in clean in 3ds Max Design and come as a body object. So that means that I still have option to further deform this object with 3ds Max deformers such as FFD box. The freeform modifier can modify the body object without requiring a polygonal tessellation, so it's keeping the curved data from the Revit in its native form. Let's have a look at the workflow with Inventor. The same thing, I will export my model into a SAT format and send it over to 3ds Max Design. Importing an SAT file from Inventor will create object in Max as BREP. Those objects maintain the curve information and tessellation is done in 3ds Max side, which give us the flexibility and lightweighted models. From here, using the architecture and design material or the pro material, it is really easy to visualize the look of your project. 3ds Max will allow you to output photorealistic images or animation and really understand the visual impact. Let's have a look at this pedestrian bridge in Rhino. Because Rhino is a NURB-based modeling software, it was impossible before to maintain the curve information when importing Rhino file in 3ds Max Design. So I'm going to just go ahead and export this pedestrian bridge using the SAT format and the Inventor preset. You will see that once import in 3ds Max Design, the curve accuracy is maintained, allowing me to further deform these body objects while still maintaining the curve information. With a non-destructive data workflow, I can start rendering my project immediately without losing any time. Let's have a quick look at this workflow. We'll start by creating an architecture and design material and make sure to use the ambient occlusion to find some definition in our models. Then we'll select everything and apply this material. From the top view, we'll create a daylight system. This will automatically turn on the mental ray exposure control and add a physical sky. We'll then turn on the hardware shading so we'll be able to adjust our sun and see the real-time shadow live in our viewports. I will also turn the hardware shading on the material so I have direct feedback on the reflection directly in my viewport. So now, when adjusting the time of the day, I can see the direct feedback in my viewport. I can see the sun and sky changing color and adjusting itself to the time of the day. I can also see the impact of the shadow on my pedestrian bridge, and I can see the nice reflection of the sunshine on my materials. Once I have decided time of the day, I will be able to adjust my exposure control. Once again, I have direct feedback in my viewport, and it's easy for me to choose which exposure works the best. So now I have a nice rendering to start with and a viewport that looks really similar. From here, it will be easy to develop more my material, add on some texture, more detail, and come up with a more final render.